How do you properly size refrigeration cycle components? Imagine trying to cool a room with a tiny fan or a huge air conditioner. Both might work, but one will be inefficient and waste energy. Proper sizing of refrigeration cycle components is just like that. It's about matching each part to the cooling needs to keep everything running smoothly. First, you need to figure out the heat load, which is how much heat the system must remove. This is called the refrigeration load. It's measured in tons of refrigeration, where 1 ton equals 12,000 British thermal units per hour. Knowing this load helps you decide how big the system needs to be. Next, focus on the evaporator. This component absorbs heat from the space you want to cool. Its size depends on how much heat it needs to absorb and the properties of the refrigerant at the inlet and outlet. You calculate the surface area needed for heat transfer and the refrigerant flow rate. If the evaporator is too small, it won't remove enough heat. Too big, and it wastes energy. Then comes the compressor. This part compresses the refrigerant vapor, raising its pressure and temperature. To size it correctly, you look at the vapor's flow rate at the suction side, which depends on the evaporator load and the refrigerant's specific volume. An undersized compressor can't handle the load, while an oversized one wastes power and causes unnecessary wear. The condenser is next. It releases the heat absorbed plus the work done by the compressor. Its size depends on the total heat to reject, which includes the evaporator load and the compressor's input power. You calculate the surface area based on the heat transfer coefficient, temperature differences, and coolant flow rate. A larger condenser can handle more heat but costs more and takes up space. The expansion valve controls how much refrigerant enters the evaporator. It must be sized to handle the mass flow rate that matches the evaporator's load. Proper sizing prevents liquid refrigerant from entering the compressor, which can cause damage. It's all about maintaining the right pressure drop and flow rate. Additional factors include using accurate thermodynamic data at key points in the cycle, considering ambient temperature, refrigerant type, and system pressures. Always include safety margins and follow manufacturer specifications. For shell and tube condensers, you need to determine the cooling water flow, tube surface area, and shell diameter to meet the heat transfer requirements. In practice, sizing starts with the known heat load, then moves through refrigerant flow calculations, thermodynamic states, and heat transfer principles. This process ensures each component is just right for the job, making the system efficient, reliable, and safe. Proper sizing isn't just guesswork. It's a careful balance of physics, calculations, and practical considerations.